This is DrClyde, and I'm going to be doing a reading from my chapter, Nutrition for Increasing Metabolism. You can see this is my website. You go to the lower left in the section called Key Readings and Handouts. I'm clicking on that. Nutrition for Increasing Metabolism. There's the reading. So I'm going to scroll down a little bit on this page so that it's front and center. And the subtitle is Making Any Diet Efficient, Including Your Natural Eating Pattern and How to Add Sports Nutrition. I put these readings kind of on a half page to 1 page length with headers so that as we're going through and as you're reading this on your own, you'll know what's coming in the next several paragraphs. So the first header is your metabolic foundation, a 1-page review before launching into nutrition. While metabolism is complex, in simple terms, it is a superficial gauge of how many calories we burn per pound of body weight each day. Metabolism is highest in our lean tissue as opposed to body fat. Managing our metabolism therefore comes to managing our lean tissue by both protecting and nourishing it. If the body does not get enough of what it needs, it will partly shut down to survive. Metabolic rate can drop by up to 1,000 calories per day from strict dieting, exercise, or particularly when doing both. People competing to lose the most weight on The Biggest Loser television show had a suppressed metabolism by as much as 800 calories per day 6 years after being on the show, making it practically impossible for them to maintain weight loss. Similarly, the calories burned from the fight or flight response of stress or from working at the expense of sleeping, raising metabolism at the moment, but hurts it afterwards. Cutting calories by dieting or burning up more calories with hard exercise can therefore backfire in the long term by suppressing metabolism. This is particularly true when the cutting and burning are done at the same time. However, we can control our metabolism and avoid metabolic suppression by protecting our lean tissue. Protecting lean tissue, PLT, means minimizing stress hormones that break lean tissue down. PLT requires sufficient sleep, stress management, and from a nutrition perspective, stabilizing both blood protein and blood sugar levels. PLT avoids the body using itself as fuel, meaning we must eat at least 75% of our daily needed calories somewhat evenly through the day. This equates to a caloric bare minimum equal to our resting metabolic rate, RMR, if we're sedentary, more if we're not. Hydration facilitates the digestion, delivery, and use of nutrients, making hydration central to both protecting and nourishing lean tissue. Nourishment implies growth and vitality, so nourishing lean tissue, NLT, goes beyond PLT. Nourishing lean tissue starts with DNA gene expression and therefore begins with deep quality sleep and any stress management that contributes to sleep. Omega fats and veggies then build upon sleep to nourish the body further. Movement, including physical activity and exercise, drive metabolism further, going beyond protection and nourishment. Now, at this point in the reading, there's a chart which separates out protecting, nourishing, and driving lean tissue, where the bottom line of protecting lean tissue is macronutrients. So maintaining a flow of water, protein, stable blood sugar, and nourishing lean tissue comes down to the quality of your sleep, not just the number of hours, and the quality of your food, not just how much or what you're eating. And then driving lean tissue is movement, including exercise. Going on with the reading. Next header. How to gauge your metabolism subjectively. Sleep, soreness, and energy. Our waking restfulness gives us a sense of our sleep quality, which is correlated to the efficiency of DNA gene expression. Our genes encode our proteins and are therefore the first step of protein production to maintain the vitality of our cells. Muscle soreness and weakness tells us how well we are recovering from exercise or from everyday wear and tear, giving us a sense of how well we are producing the proteins encoded by our genes. Our mental and physical energy levels tells us how well we are fueling basic function in the entire recovery process. Sleep, soreness, and energy therefore gives us a direct perception of the 3 key physiological steps of cellular maintenance. Protein production is a crude measure of vitality, and yet it is the simplest starting point from which all else follows. Now, at this point in the reading, I've got a chart that lists on the left how rested you feel when you wake, muscle soreness or weakness, meaning recovery, and mental or physical energy levels. And on the right, the correlations, which are, respectively, DNA gene expression from quality sleep, protein production as a first step to healing, and energy levels to fuel those processes. Moving on with the reading. Our next headline, Building Metabolic Nutrition from 3 Key Concepts Your Body Needs. macronutrient, and fuel timing and flow. Metabolic nutrition means eating to facilitate body function, which can be measured superficially simply by how many calories per pound your body is burning. Body function requires that its cells are maintained and fueled, just like a car. Maintaining our cells requires specific macronutrients, whereas fueling them generally does not. Since we're alive every moment of our lives, not only when we're eating, cells will partly consume themselves if we go for extended periods of time without eating either enough calories overall or any one of the needed macronutrients. Some regularity in the delivery of both calories and of each macronutrient is therefore important. Regularly supplying nutrients by eating to match the nutrient demand by your cells creates a supply and demand nutrient flow. Macronutrients for cellular maintenance, calories of any macronutrient for fuel, and timing for nutrient flow make up the three key concepts upon which metabolic nutrition is based. Next section, headline is, macronutrient balance maintains your cells, whereas they can be fueled by any macronutrient. Your body has protein, fat, and carbohydrate needs for specific purposes in your cells that only those macronutrient food groups can supply. Your body also needs fuel that can be provided by any combination of protein, fat, and carbohydrate. You therefore have a cellular need that must be fulfilled by specific macronutrients, as well as a fuel needs that can be fulfilled by any of them in any combination. Providing the minimum amounts of protein, fat, and carbohydrate for your macronutrient-specific cellular needs leads to the concept of eating a balanced diet. An unbalanced diet would fall short of providing enough of one of the food groups to keep your system humming along smoothly. The additional calories for fuel do not need to be balanced so long as they digest slowly enough to be used as fuel, as opposed to chronically being stored in adipose or fat cells. Your nutrition is therefore composed of two layers, a bottom foundational layer requiring balance to meet specific cellular needs, and a top layer not needing to be balanced to meet calorie needs for fuel. The bottom layer is best broken up into cellular needs with and without exercise, since exercise can more than double the amount of food needing to be balanced, such as doubling the amount of protein you need. Breaking up the bottom layer into two layers makes it clear how much of the balanced part of your diet is for normal everyday wear and tear and how much is for sports nutrition to recover from exercise, neither of which change from day to day since recovery continues on rest days. The fuel layer above these, not needing to be balanced, can also be more than doubled with exercise, but depends on how physically active you are on any given day. For intensive exercise, refueling muscle with glucose is critical to enable gene expression for healing, making the fueling part of intensive exercise partly macronutrient specific. All other fueling is flexible, enabling anyone to follow practically any diet imaginable so long as they meet their macro-specific needs and refuel their workouts. At this point, there's a couple of charts. Nutrition to raise metabolism consists of three functional layers, two for maintenance, one for fuel. So on the left-hand column, the bottom maintenance layer is basic everyday maintenance, and above that is exercise recovery and maintenance, and above that is fuel. And these correlate to macronutrient-specific needs in the maintenance layers, and then any type of calories so long as they digest slow enough to be used in the short term instead of chronically overflowing into storage. And the automobile metaphor, the maintenance layer would be building the car engine, and if there's exercise, improving that to a sports engine, and then the top layer is the fuel. Moving on, with our reading, a car has more maintenance needs if it is driven more. Likewise, the human body has basic maintenance needs that increase with exercise. Our basic maintenance needs are defined by the National Institute of Medicine, NIH, and for exercise include guidance from the International Olympic Committee, IOM, the International Society for Sports Nutrition, ISSN, and the American College of Sports Medicine, ACSM. The minimum water, protein, carbohydrate, and fat recommendations target specific physiological functions in the same way that automobile parts target specific functions. We can't build essential nutrients from each other in the same way that you can't use tires as an engine or a windshield as a transmission. Meal balance for a car would be providing it four wheels, one engine, and one transmission, whereas the type of fuel we provide can be anything we design the engine for. Likewise, meal balance for us provides our core protein, fat, and carbohydrate that we need to build and maintain our body, where any of these can then be used in any combination to fuel it. This means that building and maintaining our body requires the concept of balance, whereas fueling it does not. Building and maintaining our body makes up less than half of our needed calories. Really, it's closer to a third, and sometimes even only a fourth. Balance only applies to less than half of the food on the plate. The rest can be whatever we want, allowing us to follow and succeed with practically any diet so long as we balance the smaller maintenance part. For the fuel part making up most of our plate, digestion must be slow enough to sustain an even blood sugar. If your choice for fuel is highly processed food, such as most fast food, you can easily end up with less energy instead of being fueled by it. Eating anything you want for the fueling portion of a meal therefore implies either choosing foods that are not highly processed, or at the very least, combining healthier foods such as vegetables together with the processed foods so they digest slower together. We have tremendous dietary freedom if we consider how the body works. Next headline, the 4 macronutrients are best represented by 5 food groups to emphasize the importance of veggies. The body needs 4 nutrients in relatively large amounts, making them macronutrients. These are water, protein, fats, and carbohydrates. Water is the medium with which the others operate in the body and contains no calories, whereas the others do and can therefore be used as fuel. However, protein, fats, and carbohydrates are not only used as fuel. The genes in our DNA encode for proteins, which are the active molecules driving all activity in our cells. Fats make up the membranes of our cells and the intricate compartments within them. Carbohydrates enable cell signaling and adhesion, create viscosity and cartilage, and are the only fuel that can maintain a fully sufficient nerve signaling rate. Carbohydrates are best separated into 2 groups. One that provides more calories to fuel the body, including starches and fruits, and the other providing more micronutrients and fiber, meaning the foods that we more commonly think of as vegetables. Food group macro needs for cellular maintenance do not account for even 1/2 our calorie needs. The National Institute of Medicine, NIM, macronutrient recommendations do not provide for even half of someone's calorie needs. This is because the minimum amounts of protein, carbohydrate, fats, and vegetables are not based on getting enough calories. Instead, they're based on physiological targets, such as cellular protein production, fueling the brain, and providing enough micronutrients. These targets are unrelated to calories. A quick calculation shows how far our macronutrient needs are from meeting our caloric needs. The minimum amount of protein needed is based on how much new protein our cells produce each day, which is 30 grams, 120 calories for a sedentary 50-kilogram person. Double this if they weigh twice as much or if they are athletic. The minimum amount of carbohydrate is based on feeding the brain, 60 grams, 240 calories of glucose. The minimum vegetables are 2 cups per day, which for broccoli would be 60 calories. Essential fat requirements add up to about 150 calories, bringing the grand total for a 50-kilogram person to 570 calories per day. But a 50-kilogram person has a resting metabolic rate, RMR, of about 1,200 calories per day, which is at a bare minimum a 25% calorie restriction, since RMR does not include any food digestion or movement. Their actual calorie use is closer to a minimum of 1,600 calories per day. The 570 calories from obtaining the minimum macronutrients is not even 33% or 1/3 of the actual calories being used up by the body per day. Even if only eating enough calories to satisfy your resting metabolic rate, basic macro needs still only account for 42% of calories. Restricting calories by more than 25% reduces your metabolism substantially, in turn reducing the benefit of any further restriction. No matter who you are or how much you exercise, you need more than double the amount of food than it takes to meet your minimum macro food group needs. It should not be a surprise to us that meeting our minimum protein, carb, fat, and veggie needs do not even get us to half our minimum calories. Calories include getting enough fuel for our entire system to work properly, and of course would exceed the bare minimum protein to build new protein and the amount of fuel for the brain. We are more than just building protein and fueling our brain. So at this point in the reading, I've got a chart that lists the 4 main food groups and how much is recommended by the National Institute of Medicine, where you can just quickly on a chart see that it adds up to less than half, closer to 1/3, and for some even only 1/4 of our needed calories.